Good day, student. Come with me as we solve this 100-level physics past question compiled from University of Abuja and the Federal University of Technology, Akure. Section 1 here is from the University of Abuja, and the first question here says, state and explain the law of conservation of linear momentum. Use it to derive the principle of rocket propulsion. So the law of conservation of linear momentum simply says that in a closed system of particles, that the total momentum in the system is constant. This simply means that the total momentum before collision in a closed system is equal to the total momentum after collision. What is this saying? It's simply saying that if I have my momentum, that the momentum is simply equals to the mass times the velocity of that particular body. This is momentum in a closed system. So how does this relate to jet engine and rocket propulsion, or the principle of rocket propulsion? Now, when a jet or when a rocket is moving from the Earth's surface, it moves as the gas is expelled or the gas is exhausted. So when the gas is moving in the opposite direction, so if this is the rocket and this rocket is moving in this direction, the gas that is expelled is moving in the opposite direction. So as the gas is moving further away from the rocket is moving with higher speed or higher velocity in the opposite direction. So this makes this particular momentum to be balanced as they are both moving in opposite direction. So how does this relate in terms of formula? We know that total momentum before collision is equal to the total momentum after collision. This can simply be put to say that I have sigma P initial to be sigma of my momentum of the final. So this means that if I have the mass of the jet engine times the velocity of the jet engine to be equals to, here I will have the mass of the jet engine minus the mass of the gas expelled. Change in m here is the mass of the gas expelled. This is times, since I have mv, this will give me, here I will have the velocity of the rocket plus the additional velocity that was added by the proportion of the movement of the expelled gas. This is plus the mass of the jet engine gas that was expelled, which is changed in m, in bracket, velocity, final velocity, minus the initial velocity of the gas. So this here is what we call the rocket formula for calculating the velocity of the rocket when it is expelled that gas at that particular time. So if at the end of the day, when you simplify it, you are going to have your change in V to be equals to change in M all over M. And this is your rocket formula. Moving on to question number 2, it says, a ball is thrown vertically upward with a speed of 20 meters per second. Calculate the time to reach the highest point and maximum height attained. So in this question, we're told that the initial velocity was given as 20 meters per second. And then it said, calculate the time it takes to reach maximum height, which you do not know. Whereas asked for that to calculate the maximum height, which you also do not know. We are given G as 9.8 meters per second square. So the first thing we're going to do is to solve this question. And for us to do that, whenever a body gets to maximum height, the final velocity V is always equals to 0. So this means that my V is equals to 0 meters per second. So automatically we know that our formula is V is equals to U minus GT. So with this, why is it minus? Because the ball is
moving upward. So because it is moving vertically upward, it is moving against gravity, so it is what? Negative acceleration due to gravity. So this means that I have what? 0 is equals to 20 minus 9.8 times t. That's 9.8 t. So I'll have what? 9.8 t is equals to 20. If I divide both sides by 9.8 divided by 9.8, it means therefore that t is equal to 2.04 seconds. So I'll go further to find the what? Maximum height. And this means that my maximum height is equals to ut minus half gt squared. So this means that the maximum height therefore is equals to 20 times 2.04 minus 1 over 2 times 9.8 times 2.04 squared. So this means that my maximum height is equals to 40.08 minus 20.04. So at the end of the day, I'll get what? 20.04 meters as my final answer to question number 2. Question number 3, it says explain Kepler's 3 laws of planetary motion. Kepler stated 3 laws of planetary motion. The first law is the law of orbit. He stated the second law, which is the law of area, and the third law is the law of period. Now, the first law, which is the law of orbit, states that each planet moves in elliptical orbits with the sun at one focus. So each planet moves in elliptical orbit with the sun at one focus. It's called the law of orbit. The second law, which is the law of area, states that the line joining a planet and the sun sweeps out equal areas in equal time. The line joining a planet and the sun sweeps out equal area and in equal time. The third law is the law of period, which states that the square of the orbital period is proportional to the cube of the orbital axis. What is this saying? It's simply saying that t square is directly proportional to a cube. So this is the third law of Kepler. So this is Kepler's third law. So that's the 3 laws of Kepler. Moving on to the next question, which is question number 4. It says derive the expression for centripetal acceleration and centripetal force acting on a body moving in a circle. So we're trying to get centripetal acceleration and centripetal force. Please note that our centripetal acceleration is equal to v squared over r, where v is acting as tangential speed. So our tangential speed is v, and our arrow here is talking about the radius of the circular part of the circle. So it means therefore that my centripetal force will be equal to, since we know that ordinarily we know that force is equal to mass times acceleration, this means that my centripetal force therefore will be equal to mass times our acceleration. So this will become the formula for our centripetal force, and this is the formula for our centripetal acceleration. So that takes us to question number 5, which says a body moving at 15 meters per second. So we have the initial velocity of that body as 15 meters per second, collides with a stationary body. Because the body is stationary, our U2 is 0 meters per second. So the second body was not moving. Of equal mass. So our M1 in the question is equal to M2. They both have the same mass. And they stick together. Find their final velocity. So our V is unknown. And from the law of momentum, we know that momentum before collision must be equal to the momentum after collision. So this simply means that I have M1 U1 plus M2 U2 to be equals to V open bracket M1 plus M2. So this is the same thing as saying that I have Since my m1 is equals to m2, this can be the same thing as saying that I have m1 times my u1 there is 15 plus my m2 is m1, so I still have m1 times my u2 is 0. This is equals to v open bracket m1 plus m1. So solving further, this is the same as saying I have 15 m1 is equal to v open bracket 2 m1. So this is the same thing as saying that I have 2 v m1 is equals to 15 m1. So m1 can cancel out m1. So I have 2v is equals to 15. Divide both sides by 2 divided by 2. It means that my v is equals to 7.5 meter per second. So the answer for the final velocity to question number 5 is 7.5 meter per second. So that is also question number 6, which says describe Bernoulli's principle and derive Bernoulli's equation from the conservation of energy. Bernoulli's principle simply states that in a streamlined flow, the increase in fluid speed occurs as a result of decrease in pressure or potential energy. What this is simply saying is that from our work energy formula, we know that therefore, if we're talking about an increase in fluid speed, it means therefore that our increase in fluid speed will include our pressure plus our Ke of the fluid plus our Pe of the fluid is constant. So this is the same as saying that my pressure plus half density V squared plus density GH is equals to constant. P here, where P is pressure, rho is fluid density, V is velocity, G is acceleration due to gravity, and H here is height. So this is the formula that relates our Bernoulli's equation with the constant. So that is also question number 7, which says state and derive the equations of motion for uniformly accelerated motion. So the equations of motion state thus: the first equation of motion says that I have V is equals to U plus or minus AT. The second equation of motion says that I have S is equal to U T plus or minus half AT squared. The third equation of motion says that I have V squared is equals to U squared plus or minus 2AS. So these are the equations of motion. And then I went further to say that we should what? Derive the equations of motion. So we're going to show the derivation for each of these equations of motion. The first equation of motion was derived from the formula for acceleration, which said that my acceleration is equals to change in velocity over time. This is the same thing as saying that my acceleration is equals to V minus U over T. So if I cross multiply here, it means that I have what? V minus U is equals to what? AT. So if I move U to the other side, this simply means that I'll have that my V is equals to U plus or minus AT. So this is our first equation of motion. The second equation of motion was gotten from our average speed. We know that our average speed or average velocity is equals to total distance over total time. This is the same as saying that average velocity is equal to distance over time. So this can be further rewritten as saying that my distance is equal to average velocity times time. So you can expand this further. Since we're talking about average velocity, this is the same as saying that my distance is equal to final velocity plus initial velocity divided by 2 times time, because average what is the addition of two or more things, and dividing by the total number of things that are present there. So since we only have final velocity and initial velocity, that's why I'm having final velocity plus initial velocity divided by 2. This simply means, therefore, that my distance is equal to v plus u over 2 divided times t. So if I open the bracket, this means that I have my distance to be equal to ut divided by 2 plus, this will give me vt divided by 2. But I already know that my v is what? U plus at. So this is the same thing as saying that I have my distance to be equal to ut plus, my v here will become u plus at in bracket t, all divided by 2. So this can be simplified for that to mean that I have my distance to be equal to ut plus at all divided by 2. So this will mean that my distance is equal to 2ut plus at divided by 2, which can simply be written as saying that I have 2ut divided by 2 plus at divided by 2. So my distance therefore is ut plus 1 over 2 at. Sorry, this is supposed to be squared, because I have 80 here times t, that will give me what? 80 squared. So this will give me what? 80 squared. So this is my formula for the second equation of motion. So the third equation of motion, so from the second equation of motion, from equation 2, where we said that what? My distance is equal to u plus v divided by 2 in bracket t. And we recall that we said earlier that what v is equal to u plus at. This can simply be written as saying that v minus u is equal to at, and this is the same as saying that my t is equal to v minus u over a. So if I substitute for t here, it simply means what I'll be having is saying that my distance is equal to u plus v over 2 in bracket v minus u over a. So if I open the bracket, it means my distance will be equal to uv minus u squared plus v squared minus uv, all divided by 2a. If I cross multiply and simplify, this will mean that I have 2as is equal to v squared minus u squared. So this can be written as saying that I have v squared is equal to u squared plus or minus 2as. So this is the third equation of motion. Please note that the third equation of motion can also be gotten by what? Integrating. So you can also get the third equation of motion by integrating the second equation of motion. So when you integrate the second equation of motion, you are going to get the third equation of motion. This is the next question, which says, question number 8 says, explain projectile motion and derive the formula for maximum height and range. So we're going to derive the formula for maximum height and range. But first of all, what is projectile motion? Projectile motion is simply the motion of a body under gravity at an angle of theta. What do I mean? This is a graphical illustration of projectile motion. So this is velocity and this is time, or distance as the case may be. So if a if an object is projected from this point, it returns back to the projection plane. So it is projected at an angle of theta, and it is moving with an initial velocity of u. So when this object is projected from this point and it returns back to the projection plane, this point here is our maximum height. From here down to this point here is our range. So range is the horizontal distance, and my maximum height is the vertical distance covered by a projectile. So this is the graphical illustration of projectile motion. So they went further to say that we should derive the formula for maximum height and for range. So we derive the formula for the maximum height. Therefore, we know that our maximum height is supposed to give me u squared over 2g. So if my maximum height is u squared over 2g, and I know that since this is vertical distance, it means that my uy is equals to u sine theta. And if my uy is u sine theta, it means that my maximum height, h mass, will be equal to u sine. So this is simply saying that I have what uy squared over 2g, which is simply saying that I have what u sine theta all squared divided by 2g. So if you simplify further, this will give me u squared sine squared theta over 2g. This is my formula for maximum height. So I'll go further to what? Derive the formula for range. So because range is moving on the horizontal direction, it means therefore that my ux is what? U cos theta. And we know that here is my what? Time taken also. This is the same as saying that I have my time taken here is supposed to give me what? U sine theta over g. So if my time taken is u sine theta over g, and my range here is supposed to give me, ux times time taken. So if that is the case, this is the same as saying that I have my range to become, so my range therefore is going to give me u cos theta times u sine theta over g. So this is the same as saying that I have u squared sine theta cos theta over g. This is the same as saying I have u squared sine 2 theta over g. That is also question number 9, which says a body is dropped from a height of 80 meters. How long does it take to hit the ground? So the height was given as 80 meters, and we're asked to find the time it takes to hit the ground. Because the body was thrown on the earth's surface, our g is equal to 10 meters per second squared. So we know therefore that our height is equal to ut plus half gt squared. Why? Because it is obeying the law of gravity. And because this body was dropped from a height, it means that the initial velocity u is 0 meter per second. So this means that my h therefore is equal to what? Half gt squared, because 0 times 2 will give me what? 0. So this will give me 80 is equal to 1 over 2 times 10 times t squared. This is the same as saying I have 80 is equal to 5t squared. Divide both sides by 5, divided by 5. It means that my t squared is equal to 16. T is equal to square root of 16, which means that my t is equal to 4 seconds. So the time it takes for it to hit the ground is 4 seconds. So that is also question number 10, which says state and explain Hooke's law, and then how does it apply to springs connected in series and parallel. Now, according to Sir Hooke, Robert Hooke, he said that provided the elastic limit of a material is not exceeded, the force applied on an elastic material is directly proportional to the extension on the material. Provided the elastic limit of an elastic material is not exceeded, the force applied on the material is directly proportional to the extension of the material. Mathematically, what it was simply saying is that force is directly proportional to extension. That's the same as saying that my force is equal to kx, where K is Hooke's constant, or you can call it degree of stiffness of an elastic material. So how does this apply to springs that are connected in series and springs that are connected in parallel? When springs are connected in series, the total effective constant, the total effective degree of stiffness can be calculated as 1 over Kx, 1 over K total is equal to 1 over K1 plus 1 over K2 plus 1 over K3 till infinity. But when they are connected in parallel, when springs are connected in parallel, the total effective degree of stiffness, Kt, is given as K1 plus K2 plus K3 plus down to infinity. What does this mean? It means that when springs are connected in series, that there's a reduction in the total effective degree of stiffness in the springs, but when they are connected in parallel, the degree of stiffness increases. So that's what that question is just talking about. So that takes us to the next question, which is question number 11. It says a block of 5 kg. So we have a block of mass 5 kg is pulled across a table with a force of 20 Newton. So we have a force of 20 Newton pulling the block. If the coefficient of friction is 0.2, find the acceleration. If my mu is 0.2, find the acceleration. So acceleration is unknown. Now we know that from our equation of motion, we know from what we have gotten before under coefficient of friction, under frictional force, we know that the frictional force is equal to mu mg. So this is the same thing as saying that if this is what I have, and this can be written as saying that my force, frictional force, is equal to mu ma. So we have to find the acceleration of the body. So if I have to find the acceleration of this body, this is the same thing as saying that I have 20 is equal to, my mu is 0.2 times, the mass there is 5 times A. So this is the same thing as saying that I divide both sides by 0.2 times 5 divided by 0.2 times 5. So this is the same thing as saying that I have my A to be equals to 20 divided by 25 over 10. So this will give me 20 times 10 over 25. 5 here will give me 4, 5 here will give me 5, 5 here 1, 5 here 2. So at the end of the day, I'll get what? 8 meter per second square. So it means that the acceleration of this body is what? 8 meter per second square. That takes us to question number 11, which says a block of mass 5 kg. So we have our mass as 5 kg. Is pulled across a table with a force of 20 Newton. So we have a force of 20 Newton. That if the coefficient of friction, if my mu is given as 0.2, we have to find the acceleration. Now we know that since this is the force given, so we have to find the what? Frictional force. So the frictional force Fr is supposed to give me mu mg. And my g is supposed to be 9.8 meter per second square. So this means that my frictional force, Fr, is 0.2 times 5 times 9.8. And that will give me 9.8. 9.8. So Newton. So after I've gotten this, I'll now find the net force. So my net force is equal to the force given minus the frictional force. Since the frictional force is going to be opposing the motion, so this means that my F net, which is the net force, is supposed to give me 20 minus 9.8, and that will give me 10.2 Newton. So after I've gotten this, I'll now use this to find my acceleration. So my acceleration, my force therefore is equals to mass times acceleration. This means that my acceleration is force over mass. So this is the same as saying that my acceleration therefore is 10.2 divided by 5. And that would mean that my acceleration is 2.04 meter per second squared. So this is the acceleration of the block. That takes us to question number 12, which says, explain the difference between elastic and inelastic collision with examples. Now, elastic collision is a type of collision where both momentum and kinetic energy are conserved. So, in elastic collision, both momentum and kinetic energy are conserved. But in inelastic collision, momentum is conserved, but kinetic energy is not conserved. So, in inelastic collision, momentum is conserved, but kinetic energy is not conserved. But in elastic collision, both momentum and kinetic energy are conserved. An example of your elastic collision is the collision between two balls. So if two balls collide, moving at different velocity, after collision, they will also be moving at different velocity. So the energy is not conserved, and the word collision is also not conserved. For inelastic collision, it can be the movement of two vehicles and they crash. So if there's a car crash, for example, you discover that what after collision, the both cars will start moving with the velocity after a new velocity after the crash, and they are stuck together. So if they crash, for example, if a car crashes into a trailer, they will start moving with the velocity of the trailer after the crash. So that is what inelastic collision. So that takes us to question number 13, which says, what is the work energy theorem? Derive it using Newton's laws. So the work energy theorem is simply saying that work is directly proportional or equal to the change in kinetic energy. So work done is directly proportional to what? Change in kinetic energy, or is equal to change in kinetic energy. So what that is simply saying is that work done is equal to change in Ke. So if this is what I have, it means that my work done is equals to half mv squared minus half mu squared. So this is the work energy formula or work energy theorem. And they said we should derive it using Newton's law. Now from Newton's law, we establish that F is equals to ma. This is the same as saying that since we know that A is dv over dt, that's change in velocity over change in time, this is the same as saying that my F is equals to m dv dt. So if I divide through by dx, this will mean that I have F dx is equals to m d dv dt dx. So if this is what I have, if I differentiate this, what I'm going to be having, this will be equal to mv dv. So if I differentiate and I have mv dv, this is the same as saying if I integrate my f dx, if I integrate f dx, that's the same as saying I'm integrating mv dv. So if I integrate this, what I'm going to be having at the end of the day is going to give me half mv squared minus half mu squared. So this is the formula for work energy relationship, work energy theorem, using Newton's law to derive the formula. So that takes us to the next question, which is question number 14. It says, define torque and state its relationship with angular momentum. Define torque and state its relationship with angular momentum. Torque is simply the rotational equivalent of force. Torque is simply the rotational equivalent of force. What does this mean? It means that torque is equal to the radius times the force. So the rotational equivalent of force is what we call what? Torque. And in terms of angular momentum, it is simply the rate of change of angular momentum. So my torque is the rate of change of angular momentum, which is same as saying dl over dt, where L is angular momentum. So the rate of change of angular momentum is called torque. So my T here is time, R here is radius, and my F is force. So that is also question number 15, which says, explain the motion of a simple pendulum and derive the expression for its time period. So we are asked to explain the motion of a simple pendulum and then derive the expression for its time period. Now, a simple pendulum is a pendulum bob connected to a string, and the pendulum bob mass is recorded and the length of the string is also recorded. So we have the mass, M as mass of pendulum bob, and we have L as the length of string. So on that simple pendulum experiment, we know that our omega square is equals to G over L. And we also know that the period is 2 pi over omega. So if omega square is equals to G over L, this is the same thing as saying that my omega is equals to square root of G over L. So if I impute omega into this formula here, it means that my period will be equals to 2 pi divided by square root of G over L. So simplify this further. This will give me 2 pi times square root of L over G, which means that my period therefore is equals to 2 pi square root of L over G. So this is the formula for calculating period under simple harmonic motion. So we've come to the end of today's class. If you have any question, drop it in this comment section, and don't forget to subscribe and turn on your notification bell so that you'll be notified when we drop other videos.
Hi, I'm sure you enjoyed the video you just watched. To see more of this kind of content across all examinations, including WAEC, JAMB, JUPEP, GACAO, NEET, SAT, IELT, literally up to 100 exams, make sure you hit the subscribe button and check the channels for all of these videos and tutorials.